Good evening, everyone. This is January 2015, Unit 4 of IAL Physics. In this session, I will discuss MCQs. The first one, a particle moving in a circular path completes 7.5 revolutions in 9 seconds. What is angular velocity in radian per second? So, one revolution is equals to 2 pi radian. So, 7.5 revolutions will be equal to x cross multiply, so 7.5 into 2, so 15 pi radian. And we need angular velocity. So angular velocity is equals to angular displacement divided by time. The angular displacement is 15 pi radian and the time is 9 seconds. So when we divide 15 into 3.14 divided by 9, so this will be 15 into 3.14 divided by 9. We'll get answer in radian per second, which will come out as 5.2 radian per second. A moving pion decay into two particles y and z. This decay occur at point x. So at point x there is a decay. The particle detector and the tracks are observed from. Which of the following is a valid conclusion? So what is which one is valid conclusion? Momentum has not been conserved. So whenever there is a particle interaction or a decay, momentum is always conserved. The pion is a neutral. That is a valid. Why? Because you don't see any track of pion at point x at decay, but before that when it entered the chamber or detector, you don't find any track. So this is a valid conclusion. X and y have different masses. We cannot work out their masses because their radius of a curve x and z has y and z have a different masses. So y and z we cannot work out their masses. Why? Because maybe they have different momentums. That's why they are moving at a different curvature. So this cannot be concluded from the track. And z is negatively charged. We don't know the magnetic field, so we cannot conclude that it is negative charge. So B is the right answer. That pion is a neutral because there is no track till point x. Select a row of the table that correctly identify what happened in elastic collision. Momentum is conserved, the total energy is conserved, and the kinetic energy is also conserved. But in elastic collision, momentum is conserved, total energy, but the kinetic energy is not conserved. Question 4. A current carrying wire is placed into a magnetic field. If the magnetic force experienced by the wire balances with the weight, the wire will float. The direction of a magnetic field is from west to east. For the wire to float, it is placed. So first thing we should place perpendicular to the magnetic field. So either C can be answer or D. So what we want, like example, if I draw a compass, we have north, south, east, west. So example, if this is a compass, so weight is acting towards the center or into. We want the force to be outward. So how the force can be outward dimension? The magnetic field is from west to east. So this is the direction of the, we'll use the Fleming's left hand rule. Our first finger should point towards east. Our second finger should point in the direction of the current. So the current should move from north to south. So when the current is moving from north to south, our thumb will point outward, and that balances with the inward force of the gravity. So the perpendicular to magnetic field, so the current flows from north to south. So when the current moves from north to south, force will be outward, and that force balances with the weight which is into, and the wire will float. Two capacitors of capacitance 1000 microfarad and 10 microfarad are charged. so they can store energy, same amount of energy. So the potential, so we have the formula which relate energy stored in the capacitor is half Q into V, but we don't know Q, so Q is equals to CV. When we substitute energy stored in the capacitor is half CV square. So energy stored in capacitor 1 is same as energy stored in capacitor 2. So it will be half C1 V1 square, and this will be half C2 V2 square. So half will cancel with half. This is C, not E. So C1, the first one is 1000 micro, so it will be 10 to the power minus 6 V1 square, and E2, sorry, C2, the capacitance, that's 10 microfarad, and into V2 square. But we want V1 over V2, so V1 over V2 square is equals to 10 is to 10 to the power minus 6 divided by 1000 into 10 to the power minus 6. So this minus 6 cancel, 0 will cancel, so 1 divided by 100, that's equal to 1 exponent minus 2 or 0.01. The ratio will be there for their squares. The diagram shows path of alpha particle that is being deflected by a nucleus of an atom. The point P on a path is a point closest approach by alpha. Which statement about the alpha particle in this path is correct? It is accelerate. Its acceleration is least at P. Its acceleration is maximum. Why? Because when the object changes the direction, the acceleration will be maximum. So here it is changing the direction. Its speed is least. That's true, because to change the direction, the speed reduce and then again it increases. This is true. So B is the right answer. Its total energy is greatest at P. The total energy, why we cannot work out the total energy or the momentum is the greatest? Why? Because the speed decreases, it is having kinetic energy, so if speed decrease, the energy will also decrease. And momentum, mass into velocity or magnitude of the speed, so here the speed is decreasing, that's why it will not have a greatest momentum, it will have a greatest change in the momentum at this point. So B is a valid answer for this question. Question 7. Which of the following is not a unit of electric field? So joules, coulomb per meter. So joule is energy, coulomb is charge, and this one is distance. We have the formula. This is not electric field, E is the energy here. Because the formula for electric field, V is equals to ED, or E is equals to V divided by D. And voltage is work done per unit charge. And divided by distance. So it will be joule, coulomb, meter, or joule, coulomb inverse, meter inverse. So it can be this value. And Newton, ampere inverse, second inverse, how this can be an answer? Because we have the formula E is equals to F over Q. The force is Newton and the charge is coulomb, and coulomb is ampere second, because Q is equal, I is equals to Q divided by T. So Q is equals to IT. So ampere second. So this will be valid. Newton per coulomb, charge can be coulomb, so that's, but A is not the valid unit for electric field. A capacitor is charged to a potential of 12 volts and stored 600 microcoulomb charge. What would be the potential in order for the capacitor to store 50% more charge? We know Q is directly proportional to V. So first it was storing 600 coulomb, microcoulomb, sorry, 600 microcoulomb. So the voltage is 12. But if it is 50% more charge, 50% more charge means 900 microcoulomb. Then what will be the potential X? Cross multiply. When we multiply, it will come out as 18 volts. Which of the following is not a valid conclusion from Rutherford? A nucleus contains most of the mass. That's a valid conclusion. A nucleus contains protons only. That's wrong. It contains proton and neutron. The nucleus must be charged. That causes a deviation. A nucleus is very small compared to atom. That's also true. So B is not the valid conclusion of Rutherford experiment. A particle Z has a kinetic energy E and the momentum P. A second particle X has a twice the mass and half the momentum. The kinetic energy of X, so we have the formula that kinetic energy is half mv square. If we multiply this by divide by m, so it will be kinetic energy is equals to m square v square over 2m. And m square v square is a momentum square, so we can say kinetic energy is equals to momentum square divided by 2m. So according to this relation, the kinetic energy is directly proportional to momentum square and kinetic energy is inversely proportional to mass. So what happened? The second particle has a twice mass. So if mass is doubled, the kinetic energy will decrease by 2. The momentum is half. So this will vary with the square. So this will decrease by 4. So total change in the kinetic energy due to decrease in mass is divided by 2. Decrease in momentum is divided by 4. So total change in kinetic energy will be E by 8. So this was January 2015 of Unit 4 IAL Physics.